welcome to Inside... Ai de capul meu. Astea trebuie filmate, deci n-am cum. Lo. Hello everyone, and welcome to an insightful hour with Spyrosoft podcast series Make It Easy, where we free dive into the world of technology in the automotive industry. I'm your host, Catalin Vochita, and today we have an exciting episode lined up for you all. Joining me is our local specialist, Vlad Gradinaru from Spyrosoft Romania. So, Vlad, I think it's pretty well known that we are calling you in the office also Doctore or Doctor. I think this is coming from somewhere, from some of your history.
Yes. Hello, Catalin. Yes, I have a PhD in electrical engineering. Although I'm not professing in the line of electrical engineering where I did my PhD studies, what I learned there helped me a lot during my daily activities in functional safety. Most people think that functional safety means you read a standard and you try to impose it on others. But actually, you need to adapt, you need to research, you need to find new ways, you need to think how to apply the standard to your projects, because it's not only reading the requirements of the standard and saying, yes, you need to do that, but you need to understand what is applicable, what is not applicable. You need to offer good arguments. And my PhD years, in my PhD years, I learned that you need to do a lot of research. Most of the time you go to dead ends, but you learn from that and you come up with new solutions, you learn to be flexible, you learn to understand others, what they are facing, why some things are not really applicable. So you need to find ways to make your product to be functional safety compliant.
Okay, then it looks like it's not really connected with your, let's say, professional career, but it helped you a lot.
Exactly. Yeah.
Basically, the fundamentals are pretty close to what you are doing now, because now we are. Let's go a little bit more in the subject, because our subject is related to functional safety, right?
Correct.
And you are the expert here. And I would like to start, let's say, to discuss a little bit more in details about functional safety. And maybe we can start as a beginners, just to explain us a little bit more what it is functional safety, because from my understanding, and I saw that a lot of engineers, colleagues and so on are talking about functional safety, but it's not really exposed what really means in the end. Maybe we can start with some simple examples and just deep dive step by step.
Sure. So I think in every industry, when you develop something, when you develop a product that has a functionality or more functionalities, you need to understand what those functionalities are doing. And of course, if you have human operators or those products affect humans in any way, you need to think in when those functions do not work anymore due to some failures, because these are inherent to any product. So you don't have products which do not fail. And you need to think, okay, when those products fails and the functions are not doing what they're supposed to do, people might get harmed. So you need to avoid that. In order to avoid that, you need to understand exactly how functions can fail and how they affect humans. Be it operators or passers-by or pretty much everyone that can be around that product when it performs the function and something fails. And in automotive industry, of course, you have a vehicle that performs different functions, and you have a lot of products inside. And right now we are on the verge of automating as many driver functions as possible, with the goal of totally automating the driving experience and leaving let's say, every human inside the vehicle to be just a passenger. So it means that when you have this kind of functions, when you automate these functions like automated braking or lane keeping or lane departure prevention, so intervening in the longitudinal or lateral functions of the vehicle. You need to understand exactly if something goes wrong with those functions, what can happen, and what would be the outcome. You need to think of what can go wrong at different speeds, in different environments, be it on the city, on the highway. So in the city, you have the so-called vulnerable road users like bicyclists, motorcyclists, pedestrians that might be affected in case the vehicle fails.
But it looks like, let's say, functional safety in the end, it's taking care about, let's say, the hazard, or to control the hazard. Correct. In the end. And this is applicable, let's say, also in our industry, in automotive industry and so on. But how it looks as a basis, because functional safety is like a name, you know. And you just described that, okay, you have let's say, some factors that you need to take care to be sure that something will not happen and so on. It's any standard behind, or it's any standard who describe all the steps, what you need to do to be able in the end to control the hazard or to somehow eliminate.
Yes, so the standard for functional safety in automotive industry, it's ISO 26262. Second edition appeared in 2018, first edition 2011. Yes. And more recently, 2021, there is also another standard, ISO 21448, which handles safety of the intended functionality. So basically, what external factors. So the ISO 26262 handles internal faults. So what happens inside the ECU due to systematic or random hardware faults, systematic faults, hardware or software, or random hardware faults that can occur in time due to, let's say, aging of the PCB, of the ECU. And the other standard, the safety of the intended functionality standard, handles external factors that might affect, let's say, the precision of the functions.
Okay.
Yeah.
And let's start with an example. Maybe because we are talking about automotive industry, and maybe let's take ECU like an example, just to understand a little bit of how it is the flow, how it looks the flow, because we are talking about safety. Okay, safety, it's as you said, it's based on a standard that different processes that we need to follow and to be sure that everything goes in the right direction. But what are the main steps, let's say, in a product life cycle to be sure to start, to be sure that you will implement, you will have a product secured, safety, and so on?
First step is to define your items. So you need to know what your functions are, what is the ODD, operational design domain, and you need to understand where it operates, what are the limits of the function, where it should operate, what are the deactivating conditions, and what ECUs inside the vehicle are involved in this kind of action. So we're talking at vehicle level. And you have the function, let's say automated braking. So it means that your vehicle will brake automatically when it detects a potential collision. Especially, and this meant especially to help the drivers in case there is a surprising situation where the driver reaction is slower. So you start first with the item definition. You need to understand what your function needs to do, what are its parameters, the boundaries, and...
But this is something that your customer will, let's say, give you in the end. They are coming with some stakeholder requirements, how they are called, with some clear requirements who will describe what you are looking for, right?
That's correct. So maybe it is useful to specify that my experience lies in the ADAS domain. So I'm referring to the ADAS sensor. So indeed, the customer will come with this with the item definition, is in charge of item definition and doing the hazard analysis and risk assessment and generating the safety goals.
Maybe let's talk a little bit about those topics. You just said something about hazard analysis, how it is called, HARA.
Yeah.
And this is something which shall be done at the customer level or at our level, let's say, as a company or as a tier one.
The customer handles this hazard analysis and risk assessment because they know exactly the logic. So different OEMs have different, let's say, they spread the functionality and certain elements of the functionality differently on the ECUs. So they might have the same physical architecture. You might have the same ECUs involved in a certain function, but they assign different parts of the functionality a little bit different than other OEMs. So the OEM will come with, so it's the OEM's job to perform the hazardness and risk assessment and generate the safety goals and allocate them to the elements of the function. But it will be useful to also have an overview to better understand what will be our contribution. So you need to understand the contribution of your product, because the customer might come with safety goals, but you might develop it as a safety element out of context, so without having a certain customer in mind. And you think, okay, this function will have a safety goal or safety requirements with a certain ASIL, but the customer might come with a different perspective, and then you need to align with them on those.
And maybe just to go a little bit more, let's say, in details, how it looks, or what it is behind, because we are talking about hazard analysis and risk assessment and so on. What are the procedures behind, just to be known for everyone, by everyone, what is done during this period?
Okay, I'll try to be brief because it's a complex task. Okay, so first you need to involve the persons which are relevant. So the persons who know the function, who define the function in the first place. You need to invite people who have experience in driving testing. Okay. You need to invite people with experience in functional safety. And those people together need to let's say, brainstorm and understand how the function failed and what would be the effect of that failure at the function level. And you start by defining, okay, what are the potential failures of the function at the vehicle level. So you say, okay, braking unintentionally, or not braking when it's supposed to brake, or keeping the brakes applied when after the dangerous situation passed.
But the main focus is on hazard event or something like that you just try to...
Yes, on the hazard. You start from the hazard. So this is the effect of the failure at vehicle level. This is the hazard. And then you start to analyze exactly for each failure what are the main contributors. And you also analyze the hazard in the context of, let's say, the driving scenarios. Because a certain hazard, like unintended braking at different speeds and in different environments on a highway compared to the city, might have different effects. And in the end, it will yield a different safety goal and different ASIL. If you brake unintentionally 130 kph is different than braking unintentionally at 50 kph. So the control and how can you handle the situation is different. And you need to think, so the hazards in certain driving scenarios, and you need to identify, so you might have different hazards and in different scenarios, but the effect might be the same. So, I mean, failure in different driving scenarios which lead to similar hazards. So you can group them together to make sure that you don't analyze and derive same safety goal for different use cases.
And you just say something about safety goals. Looks like the safety goals are, let's say, the outcome from the hazard analysis and risk assessment, right?
Yes.
And safety goals are coming from the customer. Let's suppose that they are coming from the customer and are treated internally by a functional safety guy, something like that. And how it looks. Maybe just to have an example, how it looks a safety goal, what we shall understand, how we can decompose the safety goal, what is the process behind?
So for example, since we're talking about automated braking, one classical safety goal for an ADAS sensor, either that we're talking about camera, LiDAR, radar, it is prevent unintended braking within limits. And it has an ASIL B assigned. So the safety goal, it's actually, let's say, the reverse of the hazard. So if you say that the hazard at the vehicle level, at the function level, it is unintended braking, the safety goal usually it is phrased as a negation of that hazard. It's like prevent unintended braking. So you need to do all due diligence to prevent that hazardous situation to occur. This means that you need to take all the measures to prevent that situation to occur at the vehicle level. Of course, this is not all the time possible, because you cannot think of all potential situations and errors and combination of errors, but at least you need to do whatever you can based on the state of art and the current knowledge to prevent such a situation, such a hazardous situation to occur at the vehicle level. So from that safety goal, prevent unintended braking, you derive your functional safety requirements. It's like you need to protect communication, you need to detect all failures of the system that might, random failures, systematic failures that could lead to this.
This is where I would like to go, because we discussed about hazard analysis, we are at the safety goals, we've discussed about safety goals. If we are thinking about a development process, let's say, now we have the input, let's say, to be able to decompose and create our requirements maybe, and also create the architecture and so on. Let's take it step by step. And now I have the safety goals. The safety goals are treated at the system level, I think so, right?
As an input to the system.
As an input to the system level. And what happens afterwards? Because, I mean, you have the inputs for the system level, and you have not just the inputs for for safety, you have the entire, let's say,
all the stakeholder requirements.
All the stakeholders requirements. The entire system is described in the, let's say, system requirements. Let's call that. And how it looks from your perspective. What are the next steps? What you need to do? What you need to take care during this process?
Well, you have the functional safety requirements, which are generic and they are expressed in terms of what the system should do from a functional perspective to avoid violating the safety goals. So you need, okay, what do I need to do from a technical perspective? Because functions are, let's say, more or less abstract. But from the technical perspective, you need to understand, okay, what are the components that you use, what is the system architecture, physical architecture, functional architecture, and what you need to do, you need to identify the critical path, because not everything there is critical. You need to correctly identify the critical path and define the safety mechanisms at system level. And then you start allocating them to the architecture. And from that point on, you start discussing with the disciplines, with hardware and software, because they are doing the implementation.
Then it's pretty important to have even the system requirements, also the system architecture. And afterwards, you can start to elicitate and talk with, let's say, the other disciplines like software, hardware, to see how you will decompose and how you will treat the safety requirements and let's say use them as a software requirements or hardware requirements.
Yeah, this should be the normal way. From time to time, it happens that okay, you want to save some time, and hardware and software starts more or less their activities and deriving of their requirements and choosing components before they have the requirements from system. You can do this for what you already know. So, for example, you can choose, let's say, you can work together with hardware and software regarding maybe power supply architecture, or maybe how to trigger the watchdog, or maybe task monitoring. So things which are already known, you can already start discussing with them and establish some baseline, and then you can also have the requirements that will support that. But it is very important that hardware and software do not reach, let's say, their maturity where you cannot perform changes before the system is fully defined. This is very important. So it's okay to have a certain head start in development, hardware and software level, but not before the system architecture, both functional and physical, are fully defined.
Cool. That's interesting. And maybe just to, let's say, touch also this topic, during the discussion, let's say, between engineers and so on, we heard multiple times about some technical safety concept. It's like a magic box where someone is giving you all the instructions and you just take them and start to implement, let's say, during the development process. Can we talk a little bit more in details about what it is a technical safety concept, how it is, let's say, created, based on what, and so on, and what's the impact of this document in the end?
The technical safety concept, it's as defined by standard, it's composed by the technical safety requirements and the system architecture. And let's say the safety relevant part of the system architecture. the technical safety requirements, you need to define them based on the functional safety requirements and based on what you know about the architecture. So, for example, on the ADAS sensor, you already know that you have, let's say, main controlling unit, and you have the power supply to ensure the electrical energy for all the components. You maybe need an external memory because you are processing a lot of raw data. And you need also an interface with the exterior. So you have an imager in case of a camera, you have the radar antenna for the radars, you have the LiDAR ASIC that will, the laser ASIC that will get the light reflected from the vehicle. So you know exactly what kind of elements you have there, and you start defining what you need to do because it's a concept. So you need to define what you actually need to be implemented without going too much into solutions, because this is the catch. And it's specified also in the standard, but actually people do not follow it, and you always get feedback from hardware or software, yeah, be more precise because this is a very generic requirement. And you need to be, let's say, it's a trade-off. You need to be less abstract, but you need to offer the necessary details to be clear for hardware and software. And as a concept, you need to understand what you want to do, to treat it from every angle, to make sure that you don't contradict yourself, that you have clear requirements for hardware and software for them to implement, and everything it's clear and feasible from architectural point of view. You can define in requirements, you can define, I don't know, whatever you want, but it might not be feasible to realize, or it might be conflictual. So you need to be realistic.
And maybe what we didn't have the chance to talk too much, because it's strictly related, let's say, with the safety. It's about the ranking. Let's say we saw everywhere that okay, this architecture or this safety concept tells us that okay, this product or this component should be ISIL B, ISIL A, or something like that. Maybe we can have let's say a short description about what it is, what means, how they are, because it is an outcome basically. What level of ASIL should be an outcome based on hazard analysis and risk assessment, and how it is the process and what it is this outcome, how they are decomposed, how we know if it's ASIL A, ASIL B, what's the impact, if it's ASIL B, what it means something else than ASIL A, and so on.
Yeah, so we need to go back to, as you mentioned, to the hazard analysis and risk assessment, where the safety goals are derived. So when the safety goals are derived, then you say, okay, unintended braking. You need to consider the hazard, so you start from the hazard. ASIL is somehow parallel to the determination of the safety goal. The safety goal, as I said, is the negating the hazard at the vehicle level. So you need to evaluate the hazard at the vehicle level with regards to three factors: severity, exposure, and controllability. So severity, it's actually measuring the impact that it might have on human life, on human health, let's say. It can, so if the hazard occurs, it can be, let's say, with no injuries, or it can be very serious and lead to death of the driver, of a passenger, or whoever it's surrounding the vehicle. But that factor alone will not give you the, let's say, the real impact of that safety goal, because you need to measure then, okay, this hazard, how often can it occur? Well, and then you're relating yourself to the driving scenarios, right? So if you are saying, okay, this hazard, let's analyze it in different driving scenarios, like driving on highway, driving in the city, or driving in other type of scenarios, how often you can find yourself in such a situation. So driving on highway may be more frequent, and driving in the city also might be frequent. And then the severity combined with the high exposure for sure will lead to a serious situation. But then this is not the full picture. You also have a third factor, and the third factor is about the controllability. So let's say, okay, you have the hazard occurring, and how easily controllable is by the driver or by anyone else who might be involved in such a hazardous situation. So is it easy to control? Is it hard to control? And usually you need to treat these three factors together. And remember that I mentioned that you need to involve test drivers in evaluating these factors, because usually you need to think about the normal driver, right? So normal driver, it's an average of all the drivers in the world. And I think you cannot do an average, you cannot describe an average driver in one country, or it's even different from city to city. So you might have different cultural biases, or maybe you have other information, and you need to somehow to think how will a normal driver will react in such a situation. Is it feasible to control the situation? Is it not feasible to control the situation? And then you need the input from the test drivers. Test drivers are professional drivers. So if they say, for me, it is hard to control, it's normal to control, you need to dial it down a little bit and say, okay, a normal driver might be even harder to control. So somehow this is your cue in terms of controllability coming from the test drivers. And from that, you have the three factors, and once you have the three factors, you combine them and you get the ASIL. And actually the ASIL, it's a measure of the impact of the hazardous situation. So if the hazard occurs, what is actually the impact? And you measure it from ASIL A to ASIL D. It's not necessarily, I don't think you can go from ASIL A to B to C to D via logarithmic scale or whatever, so you cannot have this kind of connection. But you can think of, let's say, an ASIL A situation needs a minimum of safety mechanisms and safety measures to be deployed in order to prevent a hazardous situation to occur, while an ASIL D is quite a serious situation. So it means that the severity is high, so it can lead to the death of humans involved in a hazardous situation. It happens in a frequently met driving scenario, and it can also, it's very hard to control. So actually, this combination of factors will lead to an ASIL D. And yeah, this is how it is done. And just one thing, the ASIL is very important, at least in my opinion. The ASIL has an impact exactly on, let's say, on the development process. What do you need to do during the development process? It doesn't really have an impact, or not such a big impact, on the safety mechanisms that you choose, because I hear this kind of affirmation from a lot of people. So we need to use end-to-end protection on the communication line for ASIL B. Okay, but for ASIL D, what do you use? So actually, using certain safety mechanisms will not yield you a higher ASIL. So you can deploy all the safety mechanisms that you want, but that will not make a certain safety mechanism is not necessarily requested for ASIL B. It's like you need to use lockstep on a course for ASIL B, not necessarily. So you need somehow to judge based on the potential failure. So it's a different discussion. So you cannot really attach ASIL to a certain safety mechanism, because it's not only one safety mechanism, you have an environment of safety mechanisms that work together and might impact each other. So actually the ASIL will have an impact on how strict you need to be during the development process and what kind of activities you need to do in order to meet the required ASIL. You need to be more thorough if the hazard is serious, so it has an ASIL C, ASIL D, you need to be more thorough. You need to do more additional checks than compared to ASIL A or ASIL B to make sure that you reduce the risk as much as possible. So in the end, your goal is to reduce the risk as much as possible.
Cool. So Vlad, because we are running out of time, I would say I still have three main points that I would like to discuss, and maybe we can
wrap it up.
Put everything together. I just want to talk with you about, let's say, the safety analysis, testing, and production. How it is impacted by safety in the end. If we can just draw some lines, maybe some main factors who can impact and how it is.
Sure. So safety analysis have their importance because there you analyze what kind of faults can occur. So you need to identify first what kind of where you have your weaknesses, maybe in the design, and what kind of safety measures and safety mechanism you need to deploy in order to mitigate those risks or to close those weaknesses. And you have qualitative and quantitative analysis. Qualitative means that you address basically systematic faults, and you need to come up with some safety measures and some development process measures in order to make sure that you meet and you prevent the occurrence of those failures. And for quantitative faults, quantitative analysis, safety analysis will actually measure how good are your safety mechanisms in preventing the occurrence of random hardware faults. Whereas for testing, it is important to perform positive and negative tests. You need to perform to make sure that your safety mechanisms are working. You need to, depending on the domain, system, hardware, software, you need to deploy the necessary test methods. They are described in the standards, what is sufficient for certain ASIL to test, what kind of test methods you need to deploy. And for production, you need to define what kind of measures can be taken during production in order to make sure that you don't introduce risks. So you need maybe to do some checks, or you need to do some steps in the production line to make sure that your product in the end is actually good to use. So you don't mess up something during production that will void your entire development process.
We had a really nice discussion. A lot of informations are, let's say, pretty well described and in a good manner. And I think will be interesting to have a second chance to discuss more in detail, because for the moment we just touched, let's say, we have an overview about what means safety, how it looks. Yeah, we scratch a little bit the surface, and it's pretty nice. But for sure, I think for our audience and everyone who would like to go deeper, let's say maybe we'll have the second chance to discuss more in detail, and we can reevaluate step by step. Maybe we can have an example, I don't know. We can just play a little bit around safety. Okay, then Vlad, I would like to say thank you again for all the information that you shared with us, and for sure, see you again for another episode.
Thanks for having me.